There's Screencastify. He was thinking about it. All right. Thanks for having your cameras on. It does help me to teach more effectively with the cameras on because I could read your guys' faces and I change course as needed. So, cameras on if you can handle it today. All right, let's take a look at this because you guys have seen. Let me see. How do I explain this? Everything that we're going to look over right now, we've already touched on. Okay. There's just something called a function that is going to be a new way for us to describe different kinds of graphs, different kinds of expressions and equations. And there's really, it's almost just like a new definition. You ever learn something new and you're like, oh, that's the word for it. I already knew that. I already knew that that was like a thing. I already know something about that. It's just you learn the word about it and then you're like, oh, that's what that word means. Okay, so function, a function, here's like the basics. Okay, a function is similar to like a linear function, right? A line. We just did exponentials and linears. So everything we've been working with have been functions. A function is, a linear or an exponential. Remember exponential with the asymptote and all that, asymptote. So functions are really what we've only dealt with so far. There's this one other type of like number sentence, math type problem that is a relation, okay? A relationship are going to be our graphs that look like a circle, that look like an oval, right? And in the chat, tell me one thing that is different between these two graphs. Just anything other than, that's red ink and that's blue ink. Give me something other than the ink color. But what is different? Just like observations. There's no wrong answers. What do you see in the chat? Okay, one is linear. Perfect. So you can recognize the graph from it. Okay. One's a line, one's a circle. So they're kind of different kinds of shapes. All right. I see a lot of that one. Focus on the different kinds of shapes. Okay. Good. One connects. I see. You're saying like the circle connects on itself. That's a good observation. One's a line, one's a circle. Okay, the circle. So I see. You guys are doing great. Ooh. One goes through or close to the origin and one is around the origin. I think that's a good observation too. Okay. So here's the thing. You guys can recognize why these are different, right? You can recognize why they're different. Okay. And I like that a lot of people are saying this is a circle, right? This is a line because the function versus the relationship is exactly looking at that relationship, okay? Or that aspect of the shape, okay? When you have a function like a linear equation, like an exponential, there's one y value for every x value. There's one y value for every x value that you plug in. So if I'm here at, 1, 2, 3, if I'm here at 1, where is the y value that corresponds to x is equal to 1? I look here, and when x is 1, y is going to be right here. Okay. Remember the point and where the line has all our points that are on the function. All these points that I plugged into the equation that makes this line, they would all match and work out because those points, it's almost like cars on a street. If the car is on the street, the car is like a point on the street. So the car is a part of the function. All these points are going to fit onto this function. That's how we, when we plot points, then we connect all the dots. All those points that we're plotting are on the function and they make sense within the function. Okay. So for instance, if I plug in 1 and say this is 1 for y, if I plug in 1 for x for this equation, I would get 1 for y. Okay. If I plugged in 2 for x, maybe I would get 2.2 for y, or something like that. 3 for x, I'd get about 3 for y, right? So when you have a function, there's one y value that corresponds for every x value. Okay. Now, keep that in mind. One y value for every x value I can plug in. Now look over here. There's multiple y values for our x values. There's multiple y values. Watch. If I'm right here at x is equal to 1, right? What y values correspond to x is equal to 1? What y values? Because I look here and think about like the elevator. Think of it like an elevator. We're in the elevator number 1, right? So we have elevator number 1. Now, what are the 2 floors that those elevators go to? You can either go up here to this y value, or you can go down here to this y value. Because in this case, multiple y values for each x value. This is our x value, and we have a y value up here. We have a y value up here. And this is a relation, and a circle, an oval. There's some other weird relationships that you'll see. But this is like math 2 plus, or 2 plus, 3 plus, okay? It's not something that we're going to see too much in math 1, okay? So mainly, I want you to focus on our functions as the main thing we're focusing on. Focus. I said that too many times. This is what we're going to be dealing with, our functions. Okay, so this is the key. And I want you to just write, this is for math 1. Okay, we're mainly dealing with functions. Okay, but we still need to be able to tell if it's a function or not. Okay, now the way that we're going to do that is our next key point here. The next key point, how to test this, how to test it. The next key point is called the vertical line test. Okay, so we're going to make a vertical line. Which way is vertical? Which way is vertical? Show your hand like this or like that. Which way is vertical? Good. Raising your hand. Vertical, right? Okay. So a vertical line test is exactly that. And I have this little paper clip here. So I'm going to use that as my vertical line test. That's all you have to do to know if it's a function. Because look, up here, let's go back up here. With this, if I did the vertical line test like this, look, for the x value to 2, I have 1 y value. X is equal to 3, I have 1 y value. X is equal to 0, I have 1 y value, right? X equal to -2, I have 1 y value. Vertical line test just tells you if it's a function because there's only 1 y value for every x value. It's like perfectly corresponding. Okay, so this is a function. I'm hoping I was right because I labeled it as function. Yes. The other side of this is a relationship. And look what we had already. The vertical line test, if we apply it to a circle, look how many times for x equal to 1, how many times does it cross our graph? It crosses it 2 times, right? 2 times. How about over here? Crosses it 2 times. At x equal to 0, crosses it 2 times. You know, if you went all the way over here and you were right on there, this is called like a tangent line. It does cross it at one point, but the vertical line test has to work everywhere. So the vertical line test, you have to go, well, that's 1 point, but oh, look, cross that 2 points, 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 1 point at the very edge where it just barely touches it. But if you have a vertical line test and it crosses it twice, as it does with a circle, anywhere on the function, if it crosses it twice, it's a relation. Okay, that's the vertical line test. So let's do this. And on your paper, you can just make a dotted line, maybe another color. Make your vertical line test for the first one, and then tell me in the chat. F for function, R for relation. F for function, R for relation. What do we have here? What's this? Just do your vertical line test. It is that easy. It is that easy, guys. Good. Good. Good, Haley, Cadence. Who else has something in the chat? It's an easy answer. Ooh. Okay. Okay, good. Okay, so I want to look at this a little bit closer because there's one. Yeah, Sophia, you changed it. Okay, Sophia, tell me in the chat why you changed it. Okay, so if you're getting the names mixed up, it's no problem. After we get used to dealing with functions, that's the main thing we're going to deal with for Math 1. You won't get them messed up. Have you heard the word function before, though? You've heard the word function, right? Have you heard that in math there was something called a relation? Not really, right? Maybe you have, but it's not like a key term you've heard. So a relation is something new, and it is going to be later on in other math classes. Today, and for Math 1, we're talking about functions. All right, so I do my vertical line test. A lot of people notice this. And I see here that I'm going to end up with a function. Whoa, you guys can't see. Let me go back up a bit. Okay. So I have a function because I do the vertical line test. I cross the plot one place. Everywhere it's going to cross. Here's my x value, one y value, one y value. Here's for this x, you have one y value. This for this x, one y value. So we have a function. All right, next, you've been saying, well, what is, one sec. These are my axis lines. Okay. So in the chat, let me know. I'm going to do the vertical line test for example 2. Okay. In example 2, we have this line that starts here. It's like a water slide. It goes down, it goes over. Okay. So good. In the chat, let me know what it is. It's that easy. It's that easy. Good, 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 good. Good, good, good. Easy to observe, right? It's kind of like once you know the rule, and is that reliable, you can always trust it. All right, I see about 30 people already said relation, so that's excellent. So look, hey, but right here it doesn't cross it twice, but it doesn't matter, right? It has to be all the way across. Look, 1, it crosses at one place. Oh, it crosses at 2 places. Oh, it crosses at 3 places, 2 places, 1 place. But we had more than one situation where it crossed our vertical line more than once. If the vertical line crosses our graph, which is a little hard to see here, let me highlight it. If the vertical line crosses our graph more than once, then you have a relation. So here, relation. Okay. You may not even have to do this one. Tell me in the chat real quick. I won't spend too much time on this. Number 3. What is number 3? Good, 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 good. How fast can we all get them? Good. And even more specific, it's a linear. And linears are good. Good, 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 good. Function. Excellent. All right. How do we feel about this? Thumbs up, sideways, down for just seeing if it's a function, right? You understand like the basic of it? Like we're going to see functions more and more. You get more comfortable with it. Don't worry. Okay. Now, we're going to go on to our second page. How exciting. We're already halfway done. All right. Give me a thumbs up if you've heard the words domain and range. Have you heard the words domain and range? Okay. Some people haven't. And that's okay. Depending on how last spring went, if you're in Math 8, you may not have hit on this, okay? It's okay if it's new. It doesn't mean it's difficult just because it's new. It's just new, right? Okay, so I'm going to try to break this concept down. When we're talking about domain, it's easy. All we're talking about are the x values. Domain is talking about the x values. If I said, what was your domain? And I had this situation, I'd say, well, my domain is 0, 1, 2, and 0. Okay. You can have any numbers. You can have multiple numbers here. Right? If I was talking about the range, I'd be talking about the y values. So if I said, hey, in this table, what's the range? What are the range values? I'd say, oh, the range is 5, 7, 9, and 3. Okay. Here's a way you can remember it. Write this down next to over here. Let's write over here. Okay. Let's see. You may have recognized that x, y, the order in an order pair, like how do we know which one's the x, which one's the y? It's because it's in alphabetical order. X, Y, Z, right? Q, R, S, T, U, V, W, X, Y, Z. It's always in alphabetical order. If you're confused in math, well, which one comes first? I don't remember. It's always in alphabetical order generally, okay? Like 95% of the time. So this is how I relate this, because X and Y relate to, if I'm talking about X, I'm talking about the domain. If I'm talking about Y, I'm talking about the range. In the chat, let me know what are similar. What kind of pattern can you recognize here? Just right here. What kind of pattern can you recognize as far as X and Y relate a certain way and D and R relate a certain way. Just like how we can remember this. What's something that you can use to remember that? Yes. Not G, got it. Anybody else? Good. Good, Mud. Anybody else? Okay. You always want to have ways to remember information other than ice. Rocco, I've never heard that. That's great. That's another way to do it. Okay, good. I like that. The way I was thinking about it, and I'll give you the other way too, is that X, Y is alphabetical order. D and R are in alphabetical order. Okay? So you can remember that. Okay. X and Y is an ordered pair. In my ordered pair, the X comes first and the Y. In domain and range, the domain is talking about my X values. The range is talking about my Y values. And you know what? I just realized I want you to go ahead and get rid of these brackets here. We don't actually need brackets because that's going to confuse y'all that it's an ordered pair. It's not. So let's just go ahead and look at it this way. Because it's not an ordered pair. The other thing that came up, I like this from Rocco, has said, DR spells doctor. DR, doctor. That's one thing you can think about. If that helps you think about it. Okay. So let's look at this. When you're given a domain, okay? When you're given a domain, first, what are we talking about? Given the domain, we're talking about our X values, right? So when you're given a domain and range, your Y values, all you have to do is determine if it's a function. So let's go back and remember how easy it was to find using our vertical line test, Was this a function? No, it's a relationship. Was this a function? Yeah. Was this a function? Yeah. Okay. So with that, I say, let's go ahead and graph these points. So go ahead and on the graph, go ahead and put in these points, and we're going to see, after we graph it as best we can, we're going to try to see if it is a function or actually just, is it a function? Okay. And you know what? You don't have enough information. In Math 3 Plus, you actually learn how to graph, strange relations and functions. But just do your best. Like, take a guess on where those dots and how they're going to connect. All those points, how are they going to connect? Okay. All right, I'll give you another 30 seconds to graph those points. At least graph them. If you can't figure out how they're going to connect, that's fine. Let's just graph them. Okay, if you're still graphing, no worries. I'm going to start doing it too. 0, 5, 1, 2, 3, 4, 5. Right there. 0, 5. 1, 7, 1. We already had 5, so let's go 6, 7, and it's where those meet. 2, 9, 7, 8, 9. 2, 9. And then we have 0, 3. Uh-oh. Okay. So there's a bunch of ways you could think that those points are going to connect. I would say that it might be. I'm going to go with this. Ooh, that's weird. That's a weird one. If you didn't graph it exactly like that, maybe you were more. You just were different creatively on how you thought the graph might be. I've never actually seen a relation or function like that, but it doesn't matter. For the purpose for the purpose of this, in the chat, tell me if it's a function, give me an F. If it's a relation, give me an R. Good, good. Uh-oh. Hi, Fong, think about it. Oh, wait, what'd you put? It was going too fast. Nah, you're good. Okay. Arnold, do a vertical line test. Do a vertical line test. All right. So remember, vertical line test with my paperclip. All right, well, right here, it's kind of inconclusive. It's one overlap. Oh, two overlaps with the vertical line test. Two overlaps. Oh, definitely two overlaps right here because the same X value had two different Y values. Here, maybe there's one point that touches, but because, look, because, I can't pick it up, because one X value, here X is 0 and we end up with 5 for Y. Here X is 0 and we end up with 3 for Y. So that is a scenario where we have it's not a function, it's a relation. Okay. I'm going to write function this way sometimes, fu and x. I don't know if you ever see with other teachers, but I like writing function that way. So that's what I will do. Okay, all right. Before we move on to anything else, I would say you're going to be given some points, graph it, do the vertical line test. That's how we're going to see if it's a function. All right, thumbs up if you're feeling like you could do that, if that feels pretty good. Yeah, I think so. I'm feeling like it's going pretty well here. And we have a good 35 minutes left. You know what? This last part of the lesson is going to take just another 15 minutes. We'll do a couple example problems, and then we'll see what time it is, okay? Maybe you'll get some homework work time instead of only synchronistic teaching. All right. Next. This is like upping your guys' game. This is like, once you learn about function notation, you're going to see function notation all through college. It's like, it's the way I think about function notation. I want you to write this actually, and it's not like a traditional way, but it's a way I think to figure out like, what is it? What is function notation? Here's what I think about. It's a notation to remind you what you're plugging in. Whoops. It's a notation to remind you what you're plugging in. All right? It's a notation to remind you what you're plugging in. Okay. So here's the thing. This right here, F, this is actually the key point. If you're a little distracted by something else, really focus up here. This is the key crux of the hard part. Okay. This is not F times X in the same way that this is 2 times X. This right here is the function notation. And so far, I could write this exact same equation as this. Y is equal to 2x minus 3. That would be basic notation. That would be just x and y in a regular equation. Okay. But function notation, it's there to remind you what you're plugging in. That's like the usefulness of it. All right, Jessica, on it. Good. So we're never going to solve for this x. We're never going to, divide by f. We're never even going to change this at all. We're never going to change this at all. Okay? All this is, if I'm given a domain, which are my x values, 1, 2, and 3, and trying to find the the range, which are my y values, right? All I need to do is this. F of, it's almost like a template. That's another way to look at it. It's like a template. So go ahead and write that out, taking the x's out of here, because all function notation is telling you, or allowing you to do, is say, well, if I need to plug in 1 for x, I'm going to write it as the function. Here's my function. The function evaluated at 1. And oh, look, if I'm plugging 1 in for x, I need to plug in 1 for x. If it's a little confusing, don't worry. We'll do a couple of these examples. It will click. Trust me. All right. So when I look at this, function notation just helps me to remember what I'm plugging in. So I'm not going to change anything on the left side here. This is going to tell me that when I plug in 1 to my function, 2 times 1 is 2 minus 3. When I plugged in 1 for my function, it just helps me remember, what did I do? Oh yeah, I plugged in 1 for my function, like I did here, and I work it out, I get negative 1. So what we just figured out is we have a point at 1, negative 1. Because I plugged in 1 for x. I plugged in this x value, 1. I worked it out. The function of 1 gives us negative 1. So if I'm doing this range, I can put it like this. I put negative 1 in my range. Because all this is saying, we have different ways to show this information. We have an ordered pair, which says when we plug in x is 1, we get negative 1. We also have these brackets that we can just say all the y values in this bracket, all the x values in this bracket. That's a little bit different as well. Okay, so let's do the next one here. Let's go ahead and make our blank template. And then all you're asking is, okay, what do I have to plug in next? I just plugged in 1 because my domain had 1 in it. Now I'm going to plug in 2. Yeah, watch. All right, function notation just reminds me what I'm doing. Oh yeah, I'm doing the function where I'm plugging in x is 2, so I better put it over here as well, because that's where the x is. Okay. So I'm never touching the left side. It's going to stay as such. 4 minus 3. Function of 2 is 1. So we have a point at 2 for x, 1 for y, and I'm going to put that y value in my range. The range is my y values. The domain are my x values. Okay. All right. Lastly, what do we have to plug in now? Plug in 3. Function notation reminds me what I'm doing. That's fine to think about it like that for now. We're plugging in 3, so I better put it wherever there was an x. All right, so then you don't touch that left side. That just reminds you what you plugged in. I plugged in 3 for x. I get 6 minus 3. So f of 3 is equal to 3. So we get 3, 3. So I'm going to put my last number in there, 3. All right, put an arrow to like the first function up here. Let's see, where do I want to write it? Here we go. Put an arrow to the first answer we got, which was f of 1 is equal to negative 1. And I want you to write this. This is how you say it. Okay. Here I would write f of 1. F of 1. That's what this is. That's how I would say this. F of 1. F of 1 is equal to negative 1. That's how I would say this right here. Highlight that, or box it, or whatever, because I want you to know how to say this, okay? So that you know there's no confusion. You can understand what I'm saying here. This one, f of 2 is equal to 1. F of 2 is equal to 1. Here, f of 3 is equal to 3, right? F of 3 is equal to 3. That's how we'll say it. That's how we'll say it, okay? Now, when we're dealing with function notation, we're going to have functions, obviously. So the first section was figuring out if it's a function, and now we're learning how to do a little more with it, okay? Now, I have one more example, I think I'm going to ask you to do a screenshot so I can keep this video a little bit shorter. So I need you to screenshot this. Screenshot this this work we just did on our example. Okay, 3, 2, 1. And then I'm going to give you a little bit more space here to work on this on your own. So I want you, it's hard to see. All right, this is our exponent in this case. Our function is f of x. F of x. That's how you say this. This right here is f of x. F of x is equal to 2 times 5 raised to the x over 2. So this is just like we're having on the unit test. We have to plug in our x values, evaluating for our domain values, our x values here. Our domain is our x values. Remember, x is domain, range is y. So given the function, f of x is equal to 2 times 5 raised to the x over 2, and the domain, find the range. And we're going to express the range as an answer set. Yeah. You can call this, I want you to call this, this is a set, okay? That's a set. When you have the brackets, a set of numbers, right? All right. So give me a thumb sideways if you need me to help start the first option. Anybody need a little bit of scaffold? Thumbs down means you don't need help. Okay. Gotcha. All right, great. Yeah, thanks for all the little chat updates. All right. Nice. Jessica, you're on it. Good job. This is calculator work as well. So let me know in the chat if you're having calculator issues. And I'll ask you to hold up your calculator to see which one it is. I hope it's clicking that you know how to do each of these steps already, right? It's just a different identity for it. So you know how to plug in numbers. If you wanted help organizing a little bit, you could set up a table and put your domain, which are x values 1, 2, and 5 in there. You're finding then your range and putting it in the answer set. Good. Everyone is working. All right, for those at home, I'll just go ahead and start. First, I'm going to plug in my domain value of 1. That's my x value of 1 because domain is talking about our x values. So I'm going to go ahead and do f of 1 is equal to 2 times 5 raised to the 1 half. Remember, we plug in all function notation is doing is reminding us what we're plugging in for x. We never touch the left side. That is just our reminder of what the heck are we doing? So I'm going to go 2 to the 1 half is like 7.07 or something like that. 1 half is just a square root, so 5 square rooted. Whoops. Not even close. Why was I thinking that? 0.7? Nah, I just wasn't even close. All right, well, that happens. 2.236. I'll keep a few digits just to keep it accurate. And then I'm going to multiply that by 2. 4.47. You can always double check with Jessica. She's got the answers quick. Is the video on? Who's Jessica? No videos, but a nice sunflower crown. All right. And that tells me that f of 1, when I plug in 1, I get 4.47, which I'm going to put in my answer set, my range set here. A set is just a list of answers, a list of values that are associated with, in this case, the range. Here, this set of values is associated with the domain, which tells us it's our x value. So we're just finding our y value essentially for a table, and then just putting it in our range answer set here. All right, next we're going to go f of 2, because that's my next domain value. All right, when you're done with this, go ahead and put all your answers in the chat and put them as, you know what, let's just do this. I want you to go ahead and in the chat, I want you to put these numbers, just the range set of numbers, okay? So just with a comma, or you can even use the brackets, which are, it's the button right above the return, just right of the key P. Okay. So look on your keyboard, find P, and then to the right, the shift for that button should be the bracket. Good. 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 All right, f of 2 seems like it's going to be quick because look, f of 2 is equal to 2 times 5 raised to the, that's where I'm going to plug in my 2. Okay. So remember, function notation is just saying, what the heck are we doing again? Function notation is great for people that are forgetful. Because you're halfway through, you're like, what the heck was I doing? Oh, man. Oh, yeah, I was plugging in 2 for x. Ah, easy. Function of 2 is equal to 2. 2 over 2 is 1, so it's going to be 2 times 5, because that's 2. It's, 5 to the first power, essentially. So our function of 2, when we plug in 2 for x, we get 10 for y. So I'm going to put 10 right here. Nice. Look at all these people putting in answers. Nice. Okay, if you had the first number of 5, we should have 4.47 actually. Now I'm wondering how somebody got 5, 10, 15. Okay. Okay, they're correcting it. Perfect. Let's see. So f of 2 is equal to 10. F of 2 is equal to 10. All right. Thumbs up, sideways down. How you feeling? Is it easier than you thought? A little bit easier? All right. I see it shaking, maybe. Last one. All right, we'll see if it's 111.8. We'll see. I see different answers. Someone has 3.62. Someone has 111.8. And let's do it. The last one we have to plug in is 5. Not 3. Maybe that's why. Somebody put in 3. It's 1, 2, and they went to 5. 1, 2, and then 5 for x's. All right, maybe that's it. And I see 11.8. So we'll see. I don't know. Function of 5. F of 5 is equal to 2 times 5 raised to the 5 halves. What did function notation help us do? If you're forgetful, it helps you remember what the heck you're doing. You plugged in a function. You plugged in x equal to 5, and you ended up here. Whoops. F of 5 is equal to 2. Let's do 5 raised to the 5 halves. 5 raised to the parentheses 5 divided by 2, 5 halves. And this is 55.9. Yep, so it is 111, isn't it? F of 5 is equal to 111.8. So look, 111.8. Good. 111.8. Okay. Whew. That's it. Mm-hmm. All right. Giving the full verdict. Thumbs up, sideways, down. Thumbs up, sideways, down. Yeah, 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 yeah. Nice. Good job. It's because you guys focus, and we got some good examples down. So I will let you know. In the homework, there's like 2 problems in there that make you take this information and go one step further. But I will let you know, everything we've studied so far, you have the tools. You have like the clues from things we've already seen. You got to just connect this information. There's only like 2 problems that are going to ask you to kind of like go a little further. But this is pretty much function notation. I want to show you, I'm going to stop the video because this could like confuse folks, but I'm going to stop the video and then we'll probably end pretty soon after this. Okay, thanks for watching. All right,